Yeah, Namaste. I am Gopi Raja, CEO of Fopal Drone Tech Private Limited. People call me as Drone Raja, where I was expert in drone technologies from past 10 years. We have built some thousands of drones for agriculture and for college purpose and for different applications. Today we are going to discuss about how to make an normal F450 and F550 drones. So this is the normal F450 drone, and it's a quadcopter and it's a 450 frame. That's why it's called as F450. In the similar way, we are going to discuss about how to make a drone with F550 size also. So this is the broad view of how to make a drone till software calibration. So if you see that, first of all, we need to fix the frame motor. First of all, we need to fix the motors to the drone, motors to the frame. So to fix that, the best method is screws. No, screws. So first of all, to fix the frame, the best method is, if you can see, the no two holes are the same size. Let's say this distance is different and this distance is different. Can you see it in the frame? So the distance between this hole and this hole is different. So the best method to fix the motor is, you keep the screws, like this and hold it with your hand. Okay, and then fix the motor and make sure the wires are at the bottom of the frame. So you need to match the holes. Okay, you need to match the holes. Okay, if it was not matching, just a second only. Okay. So usually we used to keep like this, but there is an issue with this motor, so that's why we can keep it at the side, and then you fix the then you hold the motor like this, and you fix the screws. Okay, this is the way you can fix the motor perfectly to the drone. It's mandatory to fix all the 4 screws. If not, at least you need to fix 2 or 3. So make sure you fix the motor very tightly. If the motors are not fixed tightly, the drone will won't fly stably. So it's mandatory to fix the motors and screws very tightly. Okay, after fixing that, you can connect all these 3 wires randomly also, not an issue. So it's better you can pull the wires like this. It's better to you pull the wires like this, so that when the propeller spins, the wires won't hit and cut. So you can fix like this. Okay, this is the best method to fix it, because if you leave it loosely, it may hit the propeller and the wires may cut. It's better to keep like this. After that, while you are making the drone, keep fixing the motors to the frame is the first step, and second step is soldering these ESCs to the PCB is the second step, and the third step is fixing the frames, PCB and motors together like this. And make sure the red color is the back side of the drone and white color is the front direction of the drone. If you have a different color, keep the red as the back and other color at the front. You keep like this only. Most of the people, what they will do is, they will keep red, white, or else red, black, again red and black. So it's not like that. You need to make sure one color is at the back side of the drone, and this is mostly you try to fix at the right side of the drone, so that it will be easy to remove the battery. This is how you need to fix the frame. This is how you need to fix the motor, frame, ESCs. You need to fix it like this. Okay, and you can connect these wires randomly, not a problem. You can connect these wires randomly. If you don't have these pins, so you just solder this wire and you tape it, or else you heat sink it. And for the other 2 wires also, you can tape like this. You can fix all the wires and you can tape it. Later on, when you are checking the orientation of the motor, you can remove and you can change any two wires of this, so that clock will rotate anti-clock and anti-clock will rotate clock. So this is the way, this is the method how to fix the frame. And many of the people, what they will do is they will keep the top plate, and on the top plate they will keep the flight controller. So when you keep the flight controller on the top, when the drone get crashes, the flight control may get damaged. That's why majority of the cases we prefer to keep the flight control in the middle of the frame, so that it will, when the drone get crashes also, the flight control won't get any damage. And you need to bring the signal wires. In this there are three wires are there, yellow, red and black. This yellow wire is the signal wire, red wire is the VCC, and dark brown is the ground. Some cases white, red and black will be there, and that white wire is the signal. So this motor will rotate based upon the pulse signal given by the ESCs. To generate the pulse signal, this wire is very much important. There are two wires. This wire is the power wire and this is the signal wire. In this signal, this is a brown color, this yellow color wire is the signal wire. This is how you need to fix the frame. Up to this step, it's called as ARTF. Up to making drone, up to this step is called ARTF. This is called almost ready to fly. Then you need to do it the ready to fly. Ready to fly in the sense, what you need to do is, first of all, what are the transmitter you are using? Let's say when you are using a Fsi6 transmitter, or else majority of the beginners will use this transmitter only. When you are using this transmitter, the transmitter and the receiver need to get binded. So that is the called tx and rx binding. Receiver this one. Receiver. So when we switch on the transmitter, normally it shows some error. Why it shows some error is, all the sticks need to be up and the throttle need to be down. Then only it will be on properly. Otherwise it won't come. Right now you can see tx symbol only, not rx symbol. If the receiver also getting powered and if it's also binded, then it will got tx and rx symbol. Right now we have the Fsi6 receiver. Right now we are having the Fsi6 receiver. In this Fsi6 receiver, all the top wires is the signal wires, the middle wire is the VCC, and the down wire is the ground wire. Okay. In this is the first channel, second channel, third, fourth, fifth, and sixth. The last one is the binding port. You need to short the VCC and ground of this receiver. The top point of the receiver and the bottom point of the receiver, you need to short this. Then it will go to the binding mode. Then you need to keep the bind clip. So that the ground and the VCC will be shorted. Once it got shorted, then you need to power the receiver. Then you need to switch on the transmitter in the bind mode. To keep the transmitter in the bind mode, you need to press this and you need to on this. Then it will go to the bind mode. Then you need to short the signal and ground. Then it will got binded. Okay. With one transmitter, you can use number of receivers. So let's say if you have binded with this receiver, again you can change the profile of the transmitter, and again you can use the same transmitter for the different receiver. Like that, you can, with one transmitter, by changing the profiles of the transmitter, you can keep number of receivers also. Okay. So once the transmitter and receiver got binded, so there are different methods of connecting the transmitters and receiver. So one is called PWM, PPM, and S bus. PWM means for all the 6 channels. Let's say this is a 6-channel receiver. For all the 6 channels, if you use 6 different wires, then it's called PPM type of binding. So then it's called PWM binding. So for one channel, one wire, second channel, second wire, third channel, third wire. Like that, for 6 channels, if you use 6 wires, it's called PWM. Or else if you use only one wire for all the 6 channels, it's called PPM or else S bus. So right now we are using Pixhwak flight controller. In this Pixhwak flight controller, there are no 6 channels are available. So that's why what we'll do is we'll keep only this single wire. Okay. Then what will happen is this single wire will communicate for all the 6 channels. So this type of connection is called as PPM connection or else S bus connection. If you use single wire for all the connections, then it's called as PWM connection. That is the difference between the PPM and PWM connection. See, normally what will be happening is there will be something called PWM encoder. So it will take all the 6 channels, and it will convert all the 6 channels into ppm. Then it will have connected to the flight controller. That's called ppm encoder. If we don't have the ppm encoder, what we can do is we can take any three pin female to female jumper wire. You can connect it, make sure which is ground and which is VCC, and you bind it in the ppm. So that then you need to bind that receiver also in ppm. What people will do is they won't bind in the ppm, they will bind in the pwm, but they will connect the wire like this. Then the rc won't show in the mission planner. Okay, that's why when you are binding also you need to make sure it was in the ppm. I'll show you, wait. So let's say this is the transmitter, you can see it close up. Okay, I have switch on. In this the ppm output is off. If you see, the ppm output is off. Because the ppm output is off, okay, in this the ppm output is off. Because the ppm output is off, though you connected in the ppm mode, the receiver was not showing in the mission planner. That's why what you need to do is, you need to enable it ppm, again you need to bind it, then it will get calibrated. Okay, up. Once you bind the transmitter in the ppm or else pwm or else whatever the transmitter it may be, you need to do the ESC calibration or else throttle calibration. What is meant by ESC calibration or throttle calibration? If you do ESC calibration or throttle calibration, then only all motors will spin at the same time. If you don't do the throttle calibration or ESC calibration, all motors will not spin at the same time, and the drone will won't fly stably. So to make sure the drone flies stably, there is a step called ESC calibration or a throttle calibration. So to do this throttle calibration, first of all, you need to bind the receiver in PWM. So if you bind the receiver in the PWM, then only all 6 channels of the receiver will be enabled. If the receiver is in the PWM, then if you want to do the throttle calibration, it may work or it may not work. That's why what you need to do is you need to bind the receiver in the PWM first, then you need to connect the signal wire of the receiver. Let's say I want to do the, so in our case we are using a Pixhwak flight controller. And this is the front of the Pixhwak flight controller. When I connected the Pixhwak flight controller like this, then this is the front direction of the Pixhwak flight controller. Okay, this is my front direction, this is back direction of the drone. So for that, this is M1 motor, M2 motor, M3 and M4. So so what are the FC you are trying to do? You need to go to the flight controller website or else to the manual of the flight controller, and you need to check the sequence of the motors. So in our case, when we are using a flight controller called APM, Pixhwak or else crossflight, this is the first motor, and this is the second motor, and this is the third motor, and this is the fourth motor. Okay, and this must rotate anti-clock, clock, anti-clock and clock. So though it may be clock, anti-clock and whatever it may be, the ESC calibration is common for all the motors. To do the ESC calibration, you need to take the signal wire of the ESC and you need to keep it in the channel 3 of the receiver. Okay, you need to take, so this way you need to connect your transmitter and you need to connect your signal wire and the receiver. So this is the M1 motor, the M1 motor signal wire I am keeping in the channel 3 of the receiver. So then what I need to do is I need to power the drone. First time of all, I need to keep the throttle up. Okay, then I need to power the drone. The ESCs will rotate, beep, 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 beep. Then I have to give the throttle down. It will be a long beep. Okay, then I have to give the throttle up and it will start rotating the motor. This is the ESC calibration step. Right now I will do it in the live. You check it. Okay, and repeat the step for each motor 2 times. Okay, we will do ESC calibration now. Right now we are going to do the ESC calibration step. So to do the ESC calibration step, the transmitter and receiver need to be binded in the pulse width modulation mode. So to check it was binded in the pulse width modulation board, you can on the remote controller. There you can go to the system. There you can go to the RX setup. Okay, in that you can go to the ppm. You check it, it was in the off or not. If it was in the on, then the transmitter communicating the signal in the ppm. Okay, if it was off, then the transmitter is communicating in the pwm. So right now it was in the off, that's why the transmitter and receiver are communicating in the pwm, not in the ppm. Okay, so now the transmitter and receiver are communicating in the ppm, sorry, pwm. So because the transmitter and receiver are communicating in the pwm, I am giving the channel 3, throttle channel 3. You need to make sure the first two steps, the first two are empty and the third is filled with this signal wire. Make sure the signal is at the top. Make sure the signal is at the top. The signal is at the top, middle VCC and the ground. Okay, now I am powering the drone. Okay. You can see this motor is turning beep 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 beep. Just I am giving throttle and it's anti-clock. As per my drone, what I am going to make, as per my drone, what I am going to make. M1, M3, M4, sorry, M2, M4, anti-clock, clock, anti-clock, clock, and I am using APM or as Pixhwak or as crossflight. Okay, for all the flight controllers, this is the front direction of the drone. Okay, whenever you are making the drone, you need to sit at the back side of the drone. Okay, and the GPS direction, and the FC direction both need to be at the same direction only. If not, because there are two compasses, if the GPS direction is different and the FC direction is different, the drone will get crashed. Okay, in my case, I am using Pixhwak flight controller and I am using Fsi6 transmitter. I am using Fsi6 transmitter and I am using Pixhwak flight controller. In my Fsi6 transmitter flight controller, this is M1 motor. It's rotating anti-clock only, so I need not to change the motor orientation. So right now I am doing the throttle calibration. You please focusly listen how to do throttle calibration. First of all, you need to bind the transmitter and receiver in the PWM. Once the transmitter and receiver was binded in the PWM, give the throttle up, and you don't listen about all other motors. You focus on what motor you are going to do calibration, and you give the power. Beep beep beep. Throttle down. Beep beep beep, and throttle up. So it starts spinning, and when we are giving throttle up, you should not stop at the middle. At the same time, when you are giving throttle down also, while doing calibration, you should not stop in the middle. If you stop in the middle, that point will be taken as a 0. Okay, again I am doing throttle up, power the drone, beep beep beep, long beep, and throttle up. So now it was done, and I'm repeating. I have done it for 2 times. Now I am doing for the second motor. So for the second motor, give the ESC signal wire to the channel 3. First you power the motor, just wait for the signal. It will say beep 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 beep. Give throttle. It starts spinning. It's also rotating anti-clock. I need to keep it clock. So that's why this is first motor, this is third motor, second motor and fourth motor. 1 2 3 4. But I'm checking this motor now. Though the motor sequence is different, majority of the flight control will have top right motor anti-clock, clock, anti-clock and clock. So anti-clock, clock, anti-clock and clock, but it was rotating anti-clock, so that's why I was changing any two wires. Clock. So throttle up. It's rotating clock. Same step again. Throttle up. Beep beep beep. Clock. I have done it for 2 times for this motor. I'm going for the third motor. Okay. Signal wire to the channel 3. Signal wire to the channel 3 and power the drone. It's rotating anti-clock. Anti-clock, anti-clock, clock, clock. So I need not to change the orientation. So I'm going to do calibration. Throttle up. Power it. Beep 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 beep. Again I am doing for second time. Throttle up. Power it. Now I am doing it for fourth motor. Give the signal. Check the orientation. Clock. Anti-clock, anti-clock, clock, clock. So I know not to change the orientation. Just give the throttle up. Again throttle up. Power the, see major what mistakes people will do while doing throttle calibration. They won't listen the beeps. Immediately they will give throttle up or immediately they will give throttle down. So that's why the throttle calibration won't be perfect and the drone will get crashed. Though the calibration of the flight control we have done so perfectly, because of the ESC calibration was not done perfectly, the drone will get crashed. This is one method of doing each ESC and each motor and each time. There are other method is there for APM and Pixhwak flight control where we can calibrate all motors and all ESCs at a time. Okay, later on I will tell you how to do that. Okay, but the best practice is doing each motor individually. Okay, I'm giving power. Okay, so now ESC calibration was done for all the motors. Okay, so the second step, once this ESC calibration is done, if you are using a K++ flight controller or else DJ NASA flight controller, because there is no importance of physical rotation, we can keep the flight control in the center and we can calibrate it. But because there is some kind of physical orientation or else physical changes are there, keeping the FC right, keeping the FC left, front and back for the accelerometer calibration, we won't keep it directly to the frame. Okay, we'll keep this frame aside. Okay, up to this 25% of the drone has been completed. If you do it all the steps perfectly, the 25% of the drone has been done perfectly. Okay, you need to fix the motors, fix the ESCs, fix the PCB, and do the throttle or else ESC calibration. Okay, if you are using a T12 or a T10 transmitters also, if you have the Fsi6, you can do the throttle calibration with Fsi6. Or else if you don't have the Fsi6, you can keep it to the channel line of the transmitter of the T12 or else T10 remote, and you can go do this throttle calibration. Okay, and once this throttle calibration is done, now we will go with FC. So to fix this FC, what we need to do is we need to take a box. Box. ఏం ఎవరు నమ్మంటున్నారు? నాకు కుదరదని చెప్పు. సార్ కుదరదు, నిన్న నమ్మంటున్నారా? వెళ్ళు. See, though we have not connected the battery, the FC was on because it's taking 5 volts from the system. Okay, from the USB it's taking 5 volts. Okay, already transmitter and receiver got binded. That's why there is a red color LED blinking here. And here you can see TX and RX, both the symbols. Okay, because these both the symbols are there, the transmitter and receiver got binded. Okay, but it was coming to yellow color. Why it's coming yellow color is there is some error in the flight controller. If there is no error, it will come blue or green. If there is some kind of error, it will come yellow. Okay, because the flight control was not calibrated, because the accelerometric sensor and the compass sensor and frame orientation, firmware of the frame what we are going to do, and the RC calibration and pre-arm checks, battery voltage, return to home, flight mode calibration, these things have been not calibrated. That's why maybe whatever the major reason may be, it's coming yellow. So once everything was perfectly set, then it will come to blue or green. Okay, so there are some error in the flight control. We will connect it to the mission planner and we will check which error it was. Okay, right now if you can see the flight controller, there is only single wire connected between the FC and the receiver. This type of connection is called PPM, but the transmitter and receiver got binded in the PWM. I need to change it from PWM to PPM. Then only the RC will be enabled in the mission planner. Okay, so I'll off this and I'll remove the power and I will keep the receiver in the bind mode. Now I'll bind the receiver. I'll keep the receiver in the bind mode. Then I'll go to the settings. I'm going to the settings. Then I'll go to the system settings. I'll go to the PWM on. Long press, then on it will save. Again I'll go to system and I'll go to RX setup and I'll go to PPM on. So if the PPM on only, it will go to the PPM mode. And again I'll bind it. Press and on. Right now it was in the binding mode. And the receiver is also in the binding mode. I'll just power the flight controller. These both are binded. Now the receiver and the transmitter got binded. Okay, in the PPM mode. Normally there will be a PWM encoder, but right now there is no PWM encoder. That's why we have binded the transmitter and receiver directly in the PPM. Okay, so up to this step and these connections are all called as almost ready to fly. and right now we are going to do the programming. See, for majority of the drones, there is no special script. There is no JavaScript, there is no Python script, there is no C or C++ script. There are some softwares for each flight controller. Like this, for the APM and the Pixhwak flight controller, there is a software called Mission Planner. Right now, we will see how to connect the Mission Planner and how to program the drone. Okay? నేను కనిపిస్తున్నానా అవసరం లేదా నేను కనిపిస్తున్నా నేను కూడా కనిపిస్తున్నానా 1 2 3 చెక్ కట్ ప్లే చేయి వీడియో ప్లే చేసి చూడు టాప్ 1 2 3 చెక్